Okay, in this presentation we are going to look at a probability example. So what we have here is independent events. So an IT consultant is responsible for three software projects, X, Y, and Z. They know that the probability of completing project X in time is 0.99. For project Y, this probability is 0.95, and for project Z, it is 0.80. Okay. So we have three exercises here. What assumption do you need to make in order to calculate the probability of completing all three projects in time from the information given? Okay. Calculate the probability of completing all three projects on time and calculate the probability that only X and Y will be completed in time. Okay. Now, just a remark, this is an exercise aimed at beginners. First, Stats 101, so Introduction to Probability. So we're just taking a very simplistic view of things here, in case you are wondering if this is dealing with some more complex mathematics. No, it's not. Okay, so exercise A, what is the assumption needed? Well, in order to calculate the probability of completing all three projects on time based on the given probabilities, we have to assume that the completion times of all three projects are independent. So essentially, this question is about independent events, probability of independent events, which is the title of the exercise. This means that the outcome of one project does not affect the outcome of the others. Now, calculate the probability of completing all three projects on time. So this is exercise B. So what we have to do here is look at the probability of completing each project on time. So the probability of completing X in time, that is P of X equals 0.99. Probability of completing Y in time, that is P of Y equals 0.95. And likewise, probability of Z equals 0.80. So, assuming independence, the probability of completing all three projects in time is a product of the individual probabilities. So, probability of X and Y in Z, that means all three in time. That is the probability of X times the probability of Y times the probability of Z. Multiply the independent events, the probability of independent events to get the joint probability. So there we have it there. What we do is we multiply 0.99 times 0.95 times 0.80. That little dot there between 0.99 and 0.95 is just to specify multiplication. It's just a little bit easier to read. So let's see how that works out. 0.99 times 0.95 times 0.80, that works out to be 0.7524. So the probability of completing all three projects in time is approximately 75.24%. Good. Okay, now on to the last one, exercise C. Calculate the probability that only projects X and Y will be completed in time, which is to say X and Y will be completed in time and project Z will not be completed in time. So essentially what we have to do here is determine the probability of the complement of Z. So the probability of Z, C, complement of Z. The complement event means that this is not finished in time, so just have it denoted here. So I have a little C there, okay, that's to denote the complement event. And the complement event is simply, the probability of that is 1 minus the probability of Z, okay? So it's 20%, which makes sense. If it's 80% chance it's finished in time, it means that there's 20% chance that it is not finished in time, okay? And that is what the complement of Z means. So working it out here, probability of X and Y, but not Z. So X we complete in time, Y we complete in time, Z we do not complete in time. Okay, so again, these are all independent events, so what we have to do is multiply out the relevant probabilities. Probability of X times the probability of Y times the probability of the complement of Z, Z superscript C. 0.99 times 0.95 times 0.20, that works out to be 0.1881, 18.81%. Okay, and that's a wrap. We'll leave it there.